Students, today we'll discuss about areal expansion. In areal expansion, we'll consider the object which is area, that means which has two dimensions, length and breadth, for example, is more significant compared to its thickness, like a plate. So here, when you heat, the temperature will increase and its length and breadth both will change. The length originally, which is supposed to be at L0, length is L0, corresponding to temperature 0 degrees centigrade, and LT is the length of the BT is the breadth of the plate, corresponding to temperature T degrees centigrade. So the length and breadth multiplying, giving with the area at 0 degrees centigrade, that is H0, and similarly after some time T, and when the temperature is T degrees centigrade, the area will become AT, that is LT into BT. So obviously there will be a change in area. So we'll now going to discuss about how the area will change and find the final expression for the change in area. Areal expansion, first we'll write the definition, then we'll explain and derive the expression. Definition. The expansion of area is called areal expansion. Okay, when you heat, it will increase. Now, we'll explain the term. And what we are going to find is we'll consider a rod plate. Okay, a plate is considered, and let L0 is the length of the plate. It's a metal plate. So length is L0 or area is A0. Say I'll consider the area is A0, corresponding to temperature 0 degrees centigrade. Upon hitting this expands, and the area will be larger than the previous one. Suppose this is the AT, area temperature T degrees centigrade, when the temperature is increasing from 0 degrees centigrade to T degrees centigrade. So in this case, this is the transformation, that this is the original area of A0 at temperature 0 degrees centigrade is converted to AT, greater area at temperature T degrees centigrade. So our aim is to find AT. So here you must note the meaning of those terms that are involved. A0, area of plate at when its temperature is 0 degrees centigrade. AT is the area of the plate when its temperature is T degrees centigrade. AT minus A0 is the increase in area. Okay, increase in area, and T minus 0 is the rise in temperature. Okay, so we'll derive it. Derivation that it is found from the experiment that the increase in area is directly proportional to the original area at 0 degree centigrade and rise in temperature. Just like in the previous case, we discussed that the increase in length depends upon the original length at 0 degree centigrade and rise in temperature. So depends upon the increase in area is directly proportional to the original area at 0 degree centigrade and proportional to the rising temperature. So from these two, combination of these two, that increase in area part, AT minus A0 proportional to A0 and also rise in temperature. These two together will give us AT minus A0, that is the increase in area, is proportional to A0 delta T. Removing this and introducing equation with some constant to introduce, that constant is beta. One constant is introduced, that constant is beta. Beta A0 delta T. Okay. So from this we can define beta. From this we can define beta by this divided by these two terms here. But we'll first find this AT, then we'll define beta. AT becomes this minus A0 comes to the other side of the equation, becomes plus A0. This remains as it is. A0 common, 1 plus beta delta T. So this is AT. So this is the final expression. One should remember that this is the area of the plate, the solid that is under considerations when the temperature changes from 0 to T centigrade. Its area becomes this. Okay, so this is the final area at temperature T. Now we will define this beta is called what? This beta is called the coefficient of areal expansion. This beta is called coefficient of areal or superficial expansion. This is the final area, and we will define beta now. Beta is defined as this. From here we will define beta. This is an increase in area divided by, because these two will be divided here, increase in area for the original area at 0 degree centigrade for degree rise in temperature. The unit of beta will be same as the unit of alpha. As you can see here, the area will cancel out. The temperature, the unit of temperature will remain. So the unit of beta will be the unit of inverse temperature, that is for degree centigrade. That will do it here. The next page. The definition of beta, that is coefficient of areal expansion, that we discussed here. Now students will define beta, that is called coefficient of superficial expansion. That superficial expansion, as we have discussed in the last expression, the expression for AT is found to be A0 into 1 plus beta delta T. Okay, so from this here, beta is found to be, if you rearrange by definition also, if you rearrange them, this I take this inside, then I'll take pull outside, then AT minus A0 divided by A0, something like this will happen. I'm just writing it directly. The increase in area upon original area and rise in temperature. So this is the expression for beta. From this you define beta. It is the change in area or increase in area. It is defined as, so the increase in area per so this is how you define things. This divided by this and this. This is what is the basic meaning of beta. But then how to write that division of this and division of this? You say per degree, per A0, per delta T. So that you write only. It is defined as the increase in area per division means per original area at 0 degree centigrade. This area at 0 degree centigrade per, because it is divided again, per degree rise in temperature. This is change in temperature or rise in temperature. Obviously its unit will be again, if you write the unit, it will be meter square upon meter square in SI system, and temperature is Kelvin. So this will cancel and this Kelvin raised to -1. In the other units it is degree centigrade -1 or per degree centigrade. So this is the definition and unit of beta. Okay.